Welcome back, Marauders. This video, 8.4 bond polarity and electronegativity. We'll talk about different types of bonds and how we determine the bond type based on electronegativity. So we have pictures of three different bonds here. This one is between F2, so between two fluorines. And when two fluorines bond together, they share electrons very evenly. So the electrons that are being shared are right in the middle, and that's called a nonpolar bond. A polar bond occurs, for example, between hydrogen and fluorine. So if we have a hydrogen over here and a fluorine over here, they're sharing electrons, but the fluorine's a bit stronger at pulling electrons towards itself. So rather than the electrons being right in the middle, the electrons come a little bit closer to the fluorine side. So fluorine's better at pulling the electrons, and so we have more electron density over here. This bond is called polar because we have one side with a little bit of a negative charge and one side with a little bit of a positive charge. Then over here we have lithium fluoride. So the bond between lithium and fluorine. In this case, fluorine is much stronger at pulling the electron towards itself, and they're hardly sharing anymore. The electron is almost completely over here by fluorine. So here we have very even sharing, and we have a nonpolar covalent bond. Here's a polar covalent bond where they're being shared but a bit unevenly. You'll sometimes see this written with a partial negative and a partial positive charge on the two sides of the molecule. And then here is an ionic bond where they're not really being shared anymore, but fluorine completely gets one of the electrons. So how do we determine what type of bond we're going to get? Well, we look at electronegativity, and electronegativity is how strongly an element pulls electrons towards itself in a bond. This periodic table shows the electronegativity values, and you can see that electronegativity is highest in the top right corner of the periodic table and lowest in the bottom left of the periodic table. So these atoms, or these elements, are really strong at pulling electrons towards themselves because as you go towards the top of the periodic table, they're smaller. When you have a smaller radius, they can get closer to the shared electrons and therefore pull them in towards the nucleus more strongly. And as you move to the right on the periodic table, you're increasing the number of protons. So as you increase the number of protons and decrease the size, these are the ones with the highest electronegativity. They're best at attracting electrons. And down here at the bottom left, these are the largest ones with lower numbers of protons. These are the weakest at pulling extra electrons or shared electrons towards themselves. So by looking at difference in electronegativity, we can determine what type of bond we're going to have. So for our example back here, we have fluorine and fluorine. So fluorine's electronegativity from that page I just showed you is 4, and this fluorine's electronegativity is 4. So we're going to take the difference in electronegativity. This is how strongly the fluorine pulls the electron, how strongly this fluorine pulls the electron, and we have a difference in electronegativity here of 0, so it gets shared evenly. Over here between hydrogen and fluorine, if we look back at our list here, fluorine is 4.0, it has the highest electronegativity, and then hydrogen is 2.1. So we have 4.0 on this side, and we have 2.1 on this side. So it's like a tug of war, but we have the fluorine, which is much stronger at pulling the electron towards itself. And so the difference in electronegativity here, if we subtract 4.0 minus 2.1, we get a difference in electronegativity of 1.9. And a difference in electronegativity of 1.9 means that one side is significantly stronger at pulling the electron towards itself, and it'll get a partial negative charge. And then the bond between lithium and fluorine, this is an even larger difference in electronegativity. So for lithium, you have 1.0 as its electronegativity, and 4.0 for fluorine. So we have a difference in electronegativity of 3.0. So this is an even bigger difference in electronegativity, and therefore the fluorine will get even more of the electron density close to it, and this bond is considered ionic. So these are very similar in electronegativity. They share equally. These have a significant difference in electronegativity, so they share but unevenly. And then this is a really big difference in electronegativity, so it's essentially one thing taking an electron from the other. As kind of guidelines that we use, the difference in electronegativity between the two atoms tells us how polar a bond is. So typically we'll consider a bond nonpolar if the difference in electronegativity, when you subtract the difference, is between 0 and 0.4. We consider the bond to be a nonpolar covalent bond. So covalent means shared, And then nonpolar means it's sharing equally because it doesn't have a positive and negative side. A polar covalent bond typically occurs if we have a difference in electronegativity between 0.4 and 2.0. Anywhere in that range, they're sharing, but they're sharing unevenly. So one end of the atom ends up with a partial positive and one end ends up with a partial negative. And then you get an ionic bond if the difference is 2.0 to 4.0. So anything greater than 2.0 and you have an ionic bond. Now, an important thing to notice here is that there are not like definite lines between these. These are guidelines, so within this range. But if you have something that's say 2.0, it could have some characteristics of a polar bond and some characteristics of an ionic bond. It's not a definite line. It's kind of a spectrum as we change from things that are completely nonpolar to becoming more and more polar and then more and more ionic. It's not a definite line right at 2.0, but it's just different ways we can describe bonds. But it's not like a distinct change. It just becomes more and more ionic. The electrons become shared more and more unequally until it's better to describe it as one thing taking the electron from the other.